Here are some important points related to atomic structure that are commonly tested in competitive exams. 1. Atom definition. 1. An atom is the smallest unit of matter that retains the properties of an element. 2. It consists of a nucleus, protons and neutrons, and electrons orbiting the nucleus. 2. Subatomic particles. 1. Protons, p, positively charged particles found in the nucleus. 1. Their mass is approximately 1 atomic mass unit 1, AMU 1 atomic mass unit. 2. Neutrons, n, neutral particles found in the nucleus. 2. Their mass is also 1 atomic mass unit 1, AMU 1 atomic mass unit. 3. Electrons, e, negatively charged particles found in the electron cloud outside the nucleus. 3. Their mass is negligible compared to protons and neutrons. 3. Discovery of subatomic particles. 1. Electron. Discovered by J.J. Thomson in 1897 using the cathode ray tube experiment. 2. Proton. Discovered by Ernest Rutherford in 1917. 3. Neutron. Discovered by James Chadwick in 1932. 4. Atomic number, Z, and mass number, A. 1. Atomic number, Z, number of protons in an atom's nucleus, which defines the element. 2. Mass number, A, total number of protons and neutrons in the nucleus. 3. Relationship. A equals Z plus Na equals Z plus Na equals Z plus N, where N is the number of neutrons. 5. Isotopes and isobars. 1. Isotopes. Atoms of the same element, same Z, with different numbers of neutrons, same atomic number but different mass numbers. 1. Example: carbon-12, carbon-14. 2. Isobars. Atoms with different elements but the same mass number, different Z, same A. 2. Example: argon-40 and calcium-40. 6. Bohr's model of the atom. 1. Electrons revolve around the nucleus in fixed orbits or shells without radiating energy. 2. The energy of an electron is quantized, and each orbit has a specific energy. 3. The closest orbit to the nucleus has the least energy. 4. Formula for energy levels. N equals minus 13.6 EV N2 E underscore N equals, frac, 13.6, EV, N squared, N equals minus N 213.6 electron volts, where NNN is the principal quantum number. 7. Quantum mechanical model, Schrödinger model. 1. Electrons do not follow fixed orbits but are described by orbitals, probability distributions. 2. Quantum numbers describe the state of an electron in an atom. Principal quantum number, N, describes the energy level or shell. Angular momentum quantum number, L, describes the shape of the orbital, S, P, D, F. Magnetic quantum number, M, describes the orientation of the orbital. Spin quantum number, S, describes the spin of the electron. 8. Electron configuration. 1. Electrons fill orbitals starting from the lowest energy level. 2. Aufbau principle. Electrons occupy the orbitals with the lowest energy first. 3. Pauli exclusion principle. No two electrons can have the same set of quantum numbers. 4. Hund's rule. Electrons occupy degenerate orbitals singly before pairing up. 9. Aufbau order, filling order for orbitals. 1. 1's right pointing arrow, 2's right pointing arrow, 2p right pointing arrow, 3's right pointing arrow, 3p right pointing arrow, 4's right pointing arrow, 3d right pointing arrow, 4p right pointing arrow, 5's right pointing arrow, 4d right pointing arrow, 5p right pointing arrow, 6's right pointing arrow, 4f right pointing arrow, 5d right pointing arrow, 6p1s, to 2's, to 2p, to 3's, to 3p, to 4's, to 3d, to 4p, to 5's, to 4d, to 5p, to 6s, to 4f, to 5D, to 6P 1's right pointing arrow 2's right pointing arrow 2P right pointing arrow 3's right pointing arrow 3P right pointing arrow 4's right pointing arrow 3D right pointing arrow 4P right pointing arrow 5's right pointing arrow 4D right pointing arrow 5P right pointing arrow 6's right pointing arrow 4F right pointing arrow 5D right pointing arrow 6P and so on. 2. The 3D orbitals are filled after 4's. 10. Atomic spectra. 1. Atoms absorb or emit light when electrons transition between different energy levels. 2. Line spectra. Each element emits light at characteristic wavelengths when electrons move between energy levels. 3. Lyman series, Balmer series, Paschen series. These describe transitions in the hydrogen atom. 11. Heisenberg's uncertainty principle. 1. It is impossible to simultaneously determine the exact position and momentum of an electron. 12. Periodic table and atomic structure. 1. The periodic table organizes elements based on their atomic number. 2. Valence electrons. The outermost electrons involved in bonding. 2. Elements in the same group have similar valence electron configurations. 3. The position of an element in the periodic table gives insight into its atomic structure. 13. Ionization energy and electron affinity. 1. Ionization energy, i.e., the energy required to remove an electron from an atom in the gas phase. 2. Electron affinity, EA, the energy released when an electron is added to a neutral atom in the gas phase. 3. Both ionization energy and electron affinity increase across a period and decrease down a group. 14. Mass spectrometry. 1. A technique used to measure the masses and relative abundance of isotopes in a sample. 15. Radioactivity and nuclear reactions. 1. Alpha decay. Emission of a helium nucleus, 2 protons and 2 neutrons. 2. Beta decay. Conversion of a neutron into a proton with the emission of an electron. 3. Gamma decay. Emission of high-energy photons from the nucleus. 16. Hund's rule of maximum multiplicity. 1. Electrons fill degenerate orbitals, orbitals of the same energy, singly before pairing up. 17. Concept of orbitals. 1. S orbitals. Spherical in shape. 2. P orbitals. Dumbbell-shaped. 3. D orbitals and F orbitals. More complex shapes. Important formulas. 1. Energy of electron in the nth orbit of hydrogen atom. N equals minus 13.6 EVN2 E_N equals, frac, 13.6, EV, N squared, N equals minus N 213.6 electron volts. 2. Rydberg formula. 1 lambda equals R, 1 N12 minus 1 N22, frac, 1, lambda, equals R, left, frac, 1, N_1 to the power of 2, frac, 1, N_2 to the power of 2, right, lambda 1 equals R, N12 1 minus N22 1, where RRR is the Rydberg constant in N1, N2 N_1, N_2 N1, N2 are integers. These concepts provide a foundational understanding of atomic structure, which is key for success in competitive exams. Be sure to also practice numerical problems, particularly related to electron configurations, energy calculations, and atomic spectra.